In 1851, the Great Exhibition, a celebration of modern design and industry, opened at the Crystal Palace in Hyde Park. Such was its success, with 6 million people visiting over the course of 6 months, that its profits were used to purchase the Kensington Gore estate, a gore meaning a narrow triangular piece of land. Prince Albert, President of the Royal Commission for the Exhibition of 1851, envisioned this strip of land furthering the aims of the exhibition. Here, concert halls, museums and colleges would promote the influence of science and art upon productive industry. Such great buildings as the Royal Geographical Society, the Science Museum, the Royal College of Art, the National Training School for Music, subsequently known as the Royal College of Organists, the Natural History Museum and Imperial College London are all testament to the ambition of the Victorian era. Albert, who died in 1861 at the age of 42, did not live to see it all, but is remembered in the Victoria and Albert Museum, the Royal Albert Hall, and of course, the Albert Memorial. Sir George Grove, a leading musicologist who had been secretary to the original Crystal Palace, became the first director of the Royal College of Music, but resigned coincidentally in 1894 when the college relocated to its current position on Prince Consort Road, retiring to work on the 4th volume of his acclaimed Dictionary of Music and Musicians. Designed by Arthur Blomfelt, later Sir Arthur Blomfelt, the new Royal College of Music is striking for its French baronial towers framing his signature Gothic Revival style. Indeed, in 1899, even his wooden St. George's Anglican Cathedral, built in colonial Guyana, features recognisable Gothic arches and flying buttresses. But the Royal College of Music is an altogether more complex piece of architecture. Looking as if it has always been there, the red brick building has actually been shoehorned into a tight site. It is bounded by Imperial College on the west, south and east, and sits along an axis that runs from the main entrance of the Natural History Museum, through the Queen's Tower of Imperial College, and the centre of the Albert Hall, finishing at the Albert Memorial in Kensington Gardens. A testament to the unifying ambition of artistic and scientific knowledge. Rather piecemeal upgrades to this Grade II listed building over the years have resulted in some unattractive features, and a steep change in levels across the site makes for some disconcerting access arrangements, with long, narrow corridors, awkward staircases and poor wayfinding. But there are some wonders as well. The Royal College of Music's Museum of Instruments is hidden away in the basement, housing a wealth of treasures. The world's oldest strung keyboard instrument, the clavicitherium, has undoubtedly seen better days, but originates from the end of the 15th century. Thomas Hardy's Portrait of Haydn, and a wide array of various musical instruments that are still played in public concerts today. However, the main role of the college, of course, is the education of over 600 students. Its alumni include Gustav Holst, Ralph Vaughan Williams, Benjamin Britten and Michael Tippett. Then, as now, all practising in its many rehearsal rooms around the rear courtyard. And all of them, over the years, have contributed to the level of noise, admittedly often beautiful noise, filtering through into the main concert hall. So there has long been an urgent need to upgrade the main concert space in order to keep the noise out, rather more than keeping the noise in. The original concert hall was opened in 1901. It was the result of a design competition won by Sidney R.J. Smith, the favourite architect of Henry Tate, the sugar magnate. With a barrel-vaulted ceiling, decorative plaster, leaded lights and timber panelling, it has always been an imposing space. It has undergone minor changes over the years and was Grade II listed in 1995. And in 2009, the ambitious £5 million refurbishment of the hall was completed. It has been renamed the Amaryllis Fleming Concert Hall after Augustus John's daughter. A noted cellist, she studied here in the 40s. Her foundation helped fund much of the hall's improvement.
I guess that standards of noise insulation have changed a lot since 1901. And I went to one particular concert given by the Bach Choir who were visiting us. And in fact, David Wilcox, a past director, conducted one of the items, I remember. And there was a saxophone quartet rehearsing outside. And they were tuning up a semitone apart from the Bruckner motet that was about to start. We had to stop the concert. That convinced me that it was time really to soundproof the concert hall.
I think the most sensitive part of this refurbishment was around excluding the sound from outside. And this was a mixed thing, because for some people, the intrusion of a saxophone quartet during a symphony concert was rather charming and quirky. But clearly for music, you have to have a background of silence, really, from which to emerge. So getting the sound exclusion absolutely perfect so that we can use this space for recording, that we're not constantly worried that an aeroplane is going to go past, or the underground is going to rumble underneath, or worse, the soprano is going to be practicing those high notes in a way that floats in. We have none of those worries anymore, and that was the most important aspect of this work, really.
But this project has been about more than just insulation. The refurbishment concentrated on 5 key improvement areas: ventilation, acoustic separation, that is, the room's isolation from outside noise, and acoustical performance of the concert space itself, lighting, and general upgrade works. Let's look at each one in turn. The existing ventilation system was totally inadequate to modern requirements. Originally installed in the 1950s, ductwork had been crammed into the ceiling void on either side of a central walkway, and the external plant was at the end of its useful life. The project necessitated extending the roof space in order to fit the new kit. The finished lead-clad structure clings to the side of the building. It is a reasonably elegant solution to a significant problem.
The planning permissions we had to seek altogether involved the plant on the flat roof over here, where we obscured it largely with a louvered quasi-roof. We had to get planning consent again for the plant on top of the Opera Theatre, which has, again, screening around it. And that was about it, apart from a few interventions like the lead work you referred to earlier. Well, I thought that none of this external material could be seen from the public highway, but the eagle-eyed planning officers found 14 paces length of Prince Consort Road where they could actually see the plant on top of the Opera Theatre.
I think from everybody's point of view, the real difficulty was getting a modern ventilation system into a building that's over 100 years old. And the preferred method these days for ventilating a space like this is to provide cool or warm air at low level, even under the seats. It simply wasn't feasible to do that here, so we had to provide all the ventilation via high level, which meant running all the ductwork through the roof void. Now the roof void is taken up pretty much 100% by steel trusses that support the entire structure, and therefore it was necessary to thread all of the ductwork through the trusses and coordinate that with other services such as rigging, lighting, pipe services. And it was a very significant challenge, to the extent that they commissioned a 3-dimensional, fully coordinated drawing to make sure everything fitted in the right place.
The structure comprises a 25mm internal acoustic absorbent lining on an insulated steel framework with a 75mm cavity. And this has been clad in 12mm WBP plywood and finished with a standing seam Code 5 lead skin. In fact, the concert hall roof void is now more crowded with M&E equipment than ever before. But it is a much needed and much quieter development. Improving the ventilation system helped reduce M&E noise filtering into the concert hall from outside, but the building envelope still had to be insulated to stop external sounds from encroaching on public performances or rehearsals. In the original scheme proposals, the ceiling was to have remained untouched, but it became impractical to carry out the full extent of the work without removing it. This provided the opportunity to replace original ceiling vents with specifically designed ceiling coffers. Rather than making them out of 3mm plaster to match the original, each was made of jesmonite, a more sturdy, water-based, moulded material. The ceiling upgrade helped with acoustic insulation, but the main improvement has been due to the secondary glazing applied to all windows.
The windows were one of the particularly important parts of the concert hall to treat to provide further acoustic insulation. What's happened is that we've inserted a completely new secondary glazing system both to the clerestory windows at high level and to the main arched windows below, all of which have to open for cleaning purposes every now and again. But the design of the wooden frames is such that we've emulated the stonework that existed before, that the sound would not therefore be distorted by a new, say, flat face of timberwork. The glass itself is acoustically chosen by the acoustician. It's 7mm laminated glass with an acoustic quality beyond normal.
And further improvement has resulted from a new stair lobby to replace the original single door, incorporating a much-needed chair store. Its acoustic construction comprises timber panelling on 2 layers of gyprock sound block, fixed on either side of 70mm studs, packed with 50mm of mineral fibre insulation.
The first thing we did as part of the overall process was to do some measurements in this space. And we found by measurement that we got about 27 decibels of sound reduction between the lobby and the main hall. Now, to put that in context, it's quite a busy lobby at some times. It's got all hard finishes, as you may have noticed. And when you've got a group of people in there, even just talking casually amongst themselves, you can easily get noise levels in the order of 65 or 70 decibels generated. So if that's reduced by about 27, then in the hall you're looking at 40, 45 decibels. For a concert hall of this standing, you really want the background noise to be much closer to 20. So immediately our numbers indicated that there was a sound transfer problem from the lobby into the concert hall. And of course, that entirely matched the experience of the users. How to get round that was a subject of some debate with the architects, but eventually they concluded it would be feasible to put a double door arrangement separated by a lobby. So what we see now are doors immediately at the back of the auditorium, leading into a stairwell with a second set of doors at the top of the stairwell leading into the lobby. The new doors were designed to give us around 30 decibels of attenuation by the time we had them installed and put seals on them. The existing doors, which were reused, we thought we'd be able to get them up to about 30 decibels with better seals. Now, because they're actually separated by quite a distance, i.e. the stairwell lobby, those two numbers virtually combine. So between the lobby and the concert hall now, we've got about 65 decibels. And that, if you think of the original 60 to 70 we were trying to deal with, that gives us a very low background level.
Together with the upholstered seating and the new carpet, the sound reduction is a significant improvement on what was there before.
Well, I look over this balcony in awe and wonder at Mr. Smith's original design, because in fact under here was originally an examination hall, and he intended that concerts should carry on up here while chaps downstairs were taking their exams and should not be overly disturbed. As a consequence of which, we've got a big cast iron and steel structure which supports this floor, and It has a floor laid on top of it, which is the ceiling of the accommodation beneath. And then on top of that, we've got joists suspended, a big gap, and more floorboarding on top of that. So we've got an acoustic separation between this hall and the old examination hall below, which in the 1930s was converted to the Paris Opera Theatre, and the vestiges remain of that theatre down in the recording studios below us. But that was the biggest disaster college has ever had, because they were trying to perform opera below while they were trying to have a concert up here, and the two clashed inevitably because the works were never in the same key. However, the opera theatre was abandoned and has now been converted into recording studios virtually to BBC standards, which is very exciting in themselves. I do recommend you go and look at them. But on top of all that, we've got this lovely carpet with its underlay underneath, giving even greater insulation between the concert hall and the recording studios, albeit you can't hear a thing down there.
The new ceiling contains a range of access hatches, acoustic panels and air diffusers. Each tile and the surface treatment of each tile plays an important part in the acoustic modulation of the concert hall.
The actual profile of the ceiling as we see it today replicates the profile of the ceiling as it was before. So we haven't actually been able to make any significant geometric changes. We wanted to. It was quite interesting during our measurements and during our investigation. We found that the curvature of the ceiling is such that its focal point is about 1 meter above the center of the platform here. And in many respects, that's disastrous is too pejorative a term, but it's really not a welcome feature. You want in a performance space much more scattered, diffuse sound. When you get it focused like that, you end up with some quite peculiar characteristics.
Here we see a slowed down representation of the sound waves from a point source before and after. The latter providing a much more diverse sound reverberation, meaning that the hall loses its echo, and the musicians are better able to hear fellow performers on the stage.
Before we discovered this particular geometric feature, we thought we'd have to remodel the platform, cut bits out, use isolators. When we found actually that the piano sat right on the focal point, we suggested shifting it off axis, and it made quite a big difference. So some simple things, discovering them, led to quite significant improvements.
The original lighting was dated, was difficult to alter, and caused many people, especially those in the balcony, to suffer glare. The architect's new chandelier designs have incorporated several settings for a variety of concert functions, including full house lights and spotlights.
The design of the chandeliers refer to the elements within the interior of the hall, the vaulted ceiling, the arched windows and the organ pipes. We also didn't want to conceal the fibrous plaster ceiling, and therefore we pursued the idea of actually designing a frame, an exposed frame that was formed out of metal. The result was a birdcage-like frame that was entirely made of brass. We also took the advantage of the spaciousness of the hall and added height and width to the actual framework, so that the chandeliers are sympathetic to the scale and proportions of the hall.
Alongside these 1.5-ton chandeliers, there are also lighting rigs for production and ambient lighting, all of which are dimmable and programmed to avoid the need for an on-duty lighting engineer. A simple comparison with what the concert hall used to look like is enough to realise that the general decorations and upgrading works have transformed this room for the better. It is light, airy and welcoming, with an overall capacity of 500 seated guests, The dour portraits of yesteryear have been removed and the walls painted white.
Lead white paint in 1901 was the best they could do, based upon white lead oxide. Today we have white paint with titanium oxide in it, which is totally different in colour. And if one were to take some white oxide paint here and paint it on top of our walls, you'd see it much more white, much brilliant coloration. So we then had the task of saying, well, we've got all this lead everywhere. What are we going to do about that? Because it's a bit dangerous, isn't it? Well, it is, and there are regulations relating to how you can deal with lead paint on buildings, which we had to comply with. Essentially, it's all been encapsulated with new paint. That's the answer. And there are notes in the health and safety file about somebody who comes along and wants to scrape it off for some reason or other. The next step was to find out how on earth we could emulate the real colour of white lead. And again, our paint specialist was able to point us in the right direction. And what you see now is a British Standard RAL colour, the number of which completely escapes me. It is as good as we can get in terms of being close to the original colour. Now, the only bit of flamboyance we've allowed ourselves, beyond the white, is the gilding to St Cecilia all around the room, which is, I think, a little better than Mr Smith did. If you don't mind my saying so, Mr Smith, R.I.P. He was, after all, at the time of the Queen's decline, wasn't he? So everybody was being very subdued then, so we can understand that. But a little more joyous today.
Dead cables have been removed and necessary and new cabling, together with some ambient lighting, have been hidden behind extended sills. The end result is a bright, engaging and thoroughly 21st century transformation of one of the most important Victorian performance spaces in London.
I think the design intent of any project ought to be derived out of talking to the client, getting to know the site really well, and then working out a brief with the client as to where the whole thing is to go. Architects often fall down in a huge way by coming to a site and saying, I know what would be wonderful here. And that is, to me, the antithesis of what an architect should do. And here we had the joy of working with the college to work up what it was that this should be, what it should become, what it should do when we've done it. And I think largely that's happened.
Everyone's delighted with it. I've heard no adverse reactions at all from people, and Murray Pariah said some very nice things, the conductors as well. We have Proms Plus here, of course, before each prom in the summer. A lot of very good publicity and comments from the BBC, who are clearly very pleased. And after all, we are here to replicate professional conditions for the students. And I feel that we are really doing that now. I think the concert hall was already the finest in any UK conservatoire, and now it's consolidated that position.
The hall celebrated its transformation with a series of concerts, culminating with Bernard Haitink conducting Mahler's Ninth Symphony with the Royal College of Music's own orchestra. The expected annual audiences of 12,000 music lovers will now be treated to classical concerts in comfort, but without the sounds of the 21st century intruding.